Good morning, sir. Hello, am I audible?
Sir is not here.
Am I audible?
Yes, the sir is not
Yeah.
here.
And I joined from a new device. So I'm just asking for audible.
What?
We can hear you. Nothing.
Hello.
Yada.
Hello.
We can hear you, das uncle.
Hey, Kungwel, how was the math test? Hello, Kungwel. You're muted, Kungwel.
We can hear you, sir, but
I know. How did he write? Like, how did he write the test?
yeah, I did bad. I didn't know many questions, and the learning room they forgot to add the video connect.
Am I audible to all of you?
Yes,
Yes.
sir.
Yes.
Okay. Okay. So we have completed the first chapter. So today we are going to start the next chapter. That's actually the chemical change and the reactions, isn't it?
Yes, sir.
Yes.
Uh,
So I thought it was chemical reactions.
Exactly, the chemical reactions, chemical change and the chemical reactions. So can you first of all tell me what is the physical change and what is the chemical change?
So physical change is reversible or chemical change is irreversible.
Exactly. Physical change is reversible and chemical change is irreversible. And in a chemical change, we always get, yeah. In a chemical change, Yeah, we get a new product having new properties.
Yes, sir.
Okay, so can you tell me, is this screen visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so let's start then. Chemical reactions. So I will write it here. Is it visible to all of you?
Yes, sir.
Yeah, so chemical reactions. So can you define what is a chemical reaction? Any one of you?
Sir, it is the writing down of a chemical reaction.
No, what is a chemical reaction?
Oh, sorry. Chemical reaction is when two products combine to form one new product with new properties.
Exactly. So I may write that a process in which a new product is formed having new properties, isn't it?
Yes, sir.
Exactly. Formed having new properties. So any such process in which we are having a new product and which has new properties, so that change is known as chemical change, and definitely reaction will be known as chemical reaction. So any process, a process in which a new product is formed and which is having new properties. For example, just if we will write this is my carbon, it reacts with the oxygen, so what it will form?
Sir,
Carbon
carbon
dioxide.
monoxide. No, it's
Carbon
carbon
dioxide.
monoxide, right?
Right. Carbon
Carbon
dioxide.
dioxide. We
Dioxide.
are just taking it in excess, so it will form carbon dioxide. So this is a chemical reaction because here new product has formed and it is having new properties. Carbon dioxide, it is used as a fire extinguisher, isn't it?
Yes, sir.
Carbon dioxide, it is used as a
Yes,
fire extinguisher to extinguish the fire, right?
yes, sir.
Exactly. So it is used as a fire extinguisher. So it is having new properties. It's a new product which is formed when we react carbon with this oxygen. So this is a chemical reaction. Now, when we write this chemical reaction in terms of symbols and formulas, that is called the chemical equation, right?
Yes, sir.
Yes, sir.
Okay, so I will write it here that what is chemical equation. So one was the chemical reaction, another is the chemical equation. So
It's a
chemical
shorthand
equation,
representation of
exactly, it
chemical.
is the shorthand method to represent a chemical reaction. So I will write it here that it is the shorthand representation of shorthand representation of a chemical reaction. Chemical reaction in terms of symbols and formulas, isn't it?
Yes, sir.
In terms of symbols and formulas, so that will be known as chemical equation. So just as I have written down that carbon it reacts with oxygen. So now I will write the symbol, that is the C is the carbon, oxygen it is O.
SO2.
Yeah, it
Yes,
gives CO. Exactly. So this is your chemical equation. So chemical equation, it is very easy to write. It is very simplified. It is very shorthand method, and it is also better to write any chemical reaction in terms of chemical equation. Correct?
yes, sir.
Okay. So now we have to here study these types of chemical reactions. So let's here types of chemical reactions. Types of chemical reaction. So the first reaction which we are going to study here, and that is the decomposition reaction. That's a combination reaction. Exactly, combination reaction. Okay, let's study first combination. So what do you understand by this combination reaction? So it is that type of reaction in which two or more substances, they react with each other, they combine and they form a single product, right?
Yes, sir.
Okay, I will write it here, combination reaction. A reaction. So this is the short, or XN, this is the reaction, and you will write down it in detail. So a reaction in which two or more substances, in which two or more substances react to form a single product. React to form a single product. Correct?
Yes, sir.
Yeah. So that will be your combination reaction. Just as you have seen here, that this carbon, it reacts with the oxygen and it forms you the carbon dioxide. So here is the single product. So it is a combination reaction. Are you getting?
Yes, sir.
Isn't it a combination reaction? Yeah, it is a combination reaction. For example, if I will write here, I'm having magnesium. It reacts with oxygen, so it forms only one product, that's your magnesium oxide. So it is a single product. Yeah. So that means it is a combination reaction. Now, this can be element. For example, here carbon, it is the element, oxygen is the element. Sometimes it can be some compound. For example, if I will write, I'm having calcium oxide. It reacts with carbon dioxide. So it forms you the calcium carbonate, that is CaCO3. So what is this? This is also your combination reaction. Is it a combination? Can you tell me, is it a combination reaction?
Yes, sir.
Yes. Why? Because we are only having the one product, right?
Yes, yes, sir.
There is only, when there is only one single product, then you have to understand that it is a combination reaction, correct?
Yes, sir.
Exactly. So this is the very important criteria with the help of which you can tell whether it is a combination reaction or not. Simply you will just note down that if there is only single product, one product, so that's your combination reaction, correct?
Yes, sir.
Okay, so if I will write a reaction here, and that I'm having zinc oxide, it reacts with carbon dioxide and it forms the zinc carbonate. So can you tell me, is it a combination reaction?
What, sir?
Is it a combination reaction?
Yes, sir.
Exactly, it is a combination reaction because there is only one single product, isn't it?
Yes, sir.
Okay, so if I'm writing a reaction like this is CaO. Is my voice clearly audible to all of
Yes,
you?
sir. So
Yes, sir.
calcium by dioxide plus
So what it will
calcium.
form the product?
Oh, hydroxide. Okay, okay.
It will form calcium hydroxide. I will write the name. Calcium, this is your calcium oxide. You can also call it as quicklime. This is also known as quicklime. Why? Because it quickly reacts with this water and it forms the calcium hydroxide. And this calcium hydroxide, it is known as lacquered lime, right?
Yes, sir.
Lacquered lime. So I hope you will remember that lime is actually name given to such a compound which contains calcium in it. So it has calcium, so it is lime. But this is known as quicklime. Calcium oxide, it is known as quicklime. So it quickly reacts with this water and it forms this lacquered lime. That is your calcium hydroxide. So can you tell me, is it a combination reaction?
Yes, sir.
Exactly, it
Yes,
is a combination reaction because we are only having the single product. Is it right?
yes, sir.
Okay, so but now if I will just write a product here, for example, if I will write here that now I'm having this lacquered lime, that is my calcium hydroxide, and I'm just reacting it with carbon dioxide gas, and it gives me the product that is the calcium carbonate, that is CaCO3 plus water. So now can you tell me, is it a combination reaction?
No.
Is it a combination reaction?
No, no, sir.
No.
No.
No, it is not a combination reaction. Can you tell me why?
So because it two
Because there are
reactants
two
are following
products.
mu.
Exactly. So you will remember that it
Two
is
products.
yeah, it is not a combination reaction because it gives you two products. One is the calcium carbonate, another is the water. So I will write it here that it is not a combination reaction, right?
Yes, sir.
So it is not a combination reaction, but this reaction is very much important. Can you tell me where this reaction takes place?
Uh,
Sir, formation of water.
Yeah, we can form water here, and we get also the calcium carbonate. Calcium carbonate, it is your white PPT, white color it is having, white precipitate. Yeah, white. So that is why this reaction is having application in whitewash of walls. Have you heard this? White wash of walls, right? We use this
Yes,
calcium. We use this calcium hydroxide, that is the slackered lime, and when actually it gets exposed to this carbon dioxide which is present in the air, then what happens? The whole wall that becomes white. So that is called the white wash of walls. Correct?
yes, sir.
And this reaction will be
sir.
very much important, and I hope you will remember this.
Yes, sir.
Correct? Yeah, this reaction is very important in whitewash of walls. So I hope you will remember, but this is not a combination reaction. I'm repeating it again that it is not a combination reaction, right?
Sir.
Okay. So shall I move ahead? Have you written down this?
Yes, sir.
Yes.
Okay. So let's see on the next page. So then if I will write a reaction like this, that I'm having this, let's say magnesium, it reacts with the nitrogen gas and it forms the magnesium nitride. That is your Mg3 and 2. So can you tell me, is it a combination reaction?
Yes, sir.
Sir,
Exactly. It is
yes,
a
it is.
yeah, it is a combination reaction because there is only one single product, right?
Yes, sir.
Exactly. So in combination reaction, two elements can combine. Similarly, an element or a compound can combine, and sometimes two compounds may combine and they will form a single product. Correct?
Sir.
Yeah. So now let's see the next type of reaction, that is the decomposition reaction.
Yes. But one compound splits into two products.
Exactly. Decomposition reaction is that reaction in which we are having a single reactant and that gets broken down into two or more than two simpler products. So I will define it here. That decomposition reaction is that type of reaction that,
So it's just opposite of
yeah,
combination. Like
exactly.
an
It's just the
just
opposite
an
of combination.
example.
So it's that type of reaction in
I can
which,
write Mg3N2 gives 3 Mg plus N2.
okay, I will first define it, in which a single reactant, or you can say the substance, single reactant breaks down into two or more simpler products, right?
So
Yeah, so that type of reaction will be your decomposition reaction. Okay, just can you just give me the example? For example, if let's say I'm
CO
having,
gives G plus
if I'm
O2.
having, let's say magnesium carbonate, I'm having MgCO3, right?
Yes.
When I just heat it,
MgO plus CO2.
exactly, it gives MgO plus CO2.
Yes.
Sir,
So it,
electrolysis.
yeah, exactly. Electrolysis is also one of the type of decomposition. So there are actually three types of decomposition reaction. So first of all, you will remember here that we are having a single reactant that gets broken down. So single reactant breaks down. So how it gets broken down? That means some external energy is to be required, and that external energy can be in the form of heat, in the form of
Heat,
light,
light,
yeah, in the form of
electricity.
electricity. Exactly. So that is why we are having the three types of decomposition reaction. So I will write here
Thermal
three types of,
decomposition.
Three types of decomposition reaction.
Photochemical.
Three types of decomposition reaction. So number first is the thermal decomposition reaction, right?
Yes, sir. Like, because of heat, it's getting decomposed.
Exactly. Therm means heat, so thermochemical decomposition reaction. Thermochemical decomposition reaction, or you can also thermal decomposition reaction, right?
Yes, sir. Thermal.
Yeah, thermal.
Can I
So
do-
therm means heat. Thermal decomposition. So that means here the energy
sir.
external factor which actually causes the decomposition, that is the heat in presence of heat. Exactly. So heat energy is required in order to break the reactant or the substance into two or more than two simpler products. We require the heat energy. So heat energy is required in case of thermochemical decomposition or thermal decomposition reaction. So heat energy is the here the necessary condition. So for example, if I'm having this zinc carbonate, that is ZnCO3. So if I'm just in chemistry, we represent heat by this delta sign, by this triangle. I hope you know this, right?
Yes, sir.
Yeah, so this is the symbol for heat in chemistry. So what will be the product here?
Sir,
Zinc
zinc oxide with carbon dioxide.
Exactly, zinc oxide plus carbon dioxide. Right?
Yes, sir.
Okay, so similarly, if I'm having this lead nitrate, that is PbNO3 whole twice.
Oxide plus nitrogen.
Lead oxide, okay, plus
Nitrogen.
nitrogen dioxide plus oxygen.
Oh,
Can you,
yeah.
can you balance this? If I will write twice,
Sir, 3 NO2.
4 times NO2, because we are having here 2 to the 4.
Oh, yeah. Okay.
Oxygen, we are having how many? 3 to the 6, 6 to the
Sir,
12.
I think we have 5 on this side.
On the reactant side, how many oxygen we are having?
6. Oh, no, wait. We are 12.
On the reactant side, how many oxygen atoms we are having?
12.
Currently 12.
Exactly, we are having 12 oxygen atoms on the reactant side. So can you tell me on the product side, we are having 2 here and 8 here, that's 10 and 2 12, right? It is balanced.
4 plus 8.
Is it balanced?
Yes, sir.
Yeah, exactly, it is balanced. Now, can you tell me here that this nitrogen dioxide which is formed here, which color it is having, nitrogen dioxide gas?
What, sir?
Nitrogen dioxide here which is formed, that is NO2, it is having brown color, brown vapors are formed, right? Brown vapors. So I hope you will remember this reaction. So this was our lead nitrate. When it decomposes, when it is heated, we get the lead oxide, we get the nitrogen dioxide having brown color, and we get the oxygen gas. This reaction will be very, very important. You will note down this.
Yes, sir.
Yeah, you just note down this. This is very important that it is your lead nitrate. So lead nitrate, when it is actually heated, you just get the lead oxide, and along with that you get the nitrogen dioxide gas which is having brown color. So sometimes it is asked in your exam that which substance, when it undergoes thermal decomposition, that gives the brown vapors. So it is the lead nitrate.
Oh, sorry, sir.
Okay, have you noted down this now?
Yes, I almost finished.
So I'm again repeating that lead nitrate, when it is heated, it gives us lead oxide, and the nitrogen dioxide gas, it is having brown color. So brown vapors of nitrogen dioxide vapors are formed. Along with that, we also get the byproduct oxygen, O2. Noted? Have you now noted down this?
Yes, sir. Nitrogen dioxide is gas, right?
Yeah, and nitrogen dioxide, it is a gas, nitrogen dioxide. So I will give you the next example. For example, now if I'm having copper sulfate pentahydrate, this is 5 times water here. So this is known as, I will write its name here, that is the copper sulfate pentahydrate. Penta means there are 5 water molecules. So now when it is heated, what actually happens here? So it was your height. Exactly. It is having blue color, so that's why it is known as blue vitriol, right?
Yes, sir.
Yeah, it's known as blue vitriol. So when it's heated, what you will get? You will get the anhydrous copper sulfate. So all these 5 water molecules, they will just get removed from this. So 5 times H2O. So that means it becomes anhydrous. And when it becomes anhydrous, it is not having blue color. So blue color is when there are 5 water molecules attached to this. Isn't it?
Yes,
Yeah. So can you tell me what is green vitriol then?
sir. I think
It is definitely your iron sulfate. Yeah, heptahydrate. Iron sulfate heptahydrate. This is known as green vitriol.
yes, sir.
Green vitriol. It is having green color. So when it is heated, it will also become anhydrous. That means water. Yeah, water molecules will get removed, so it will become only FeSO4.
Iron sulfate.
Yeah, iron sulfate heptahydrate. It's known as hepta. Hepta means 7, not hexa. Hepta. I will write it here. It is heptahydrate.
Oh, hepta. Okay, sir.
Yeah. Okay, got it now?
Yes, sir.
Okay, then let's give another example. Can you tell me what is white vitriol? So blue vitriol is copper sulfate pentahydrate. Green vitriol is iron sulfate. Then what is white vitriol?
Is it aluminum?
This is zinc sulfate. Zinc sulfate heptahydrate, that is your white vitriol. So when it is heated, it also gives you the zinc sulfate, and we also get here 7 times water. So this was your white vitriol, right?
Yes, sir.
So any doubt here?
No, sir.
So this was your one of the thermal decomposition reaction, one of the type of decomposition reaction. Now another is the photochemical decomposition.
Passage of
Photochemical.
light.
Yeah, exactly. That means this decomposition reaction takes place in presence of light. Photochemical decomposition. So photochemical decomposition, it is also known as photolysis. Photolysis, or you can say photolysis reaction. So that means this type of reaction, it takes place in presence of light.
Sunlight.
Yeah, exactly, in presence of sunlight.
Any light, maybe.
In presence
No,
of
only
sunlight.
sunlight.
No, it can also happen to artificial UV rays.
Exactly, we can have any type of light which should have minimum amount of energy in order to decompose that substance. We can use any type of light, but it should have sufficient amount of energy so that it can decompose the substance, right?
Yes, sir. It's
Yeah.
common in
You will,
silver.
yeah, artificial ultraviolet radiations, they can also decompose. For example, I will give you the example. Just we are having this silver bromide. So this type of reaction is actually used in photoelectric devices, that is the cameras.
Silver plus bromide.
So in presence of this sunlight, so can you tell me what happens to this silver bromide?
Silver bromide. Silver plus bromide.
Exactly, you will get the silver and you will get the bromine, that's Br2. Yeah, so this silver, it is having the gray color. So that is why it is used in we are having the cameras. In cameras, inside the camera, we are having the camera roll, that is a photographic film. So this silver bromide, it is used in photography.
The films.
Yes, the photographic films. On the photographic film, there is a coating of silver bromide. So that's why
So it's
you will remember.
brown in color, right?
Yeah, exactly. Black and white color photograph which is obtained. That is actually due to this reaction. So that's why you will remember this reaction that it is used in photography. I hope you will remember this. You
Yes.
noted down this. Yeah, so this reaction, that is the silver bromide, it in presence of sunlight, it decomposes, it gives us silver and bromine. So you can just balance it like this, twice here AgBr and twice here Ag. Is it balanced?
Yes.
Yes, sir.
Exactly, it is balanced. So this is your also decomposition reaction, but it is known as photochemical because it takes place in presence of light, sunlight. Okay, so this is your AgBr, silver bromide. Then let's see the next one reaction that is actually also the photochemical or the photolysis, that is silver chloride, that is AgCl. So when light falls on this, I can also write light in just like this H nu. So can you tell me what is this H nu?
So lights.
Sir, what is the HV?
Yeah, it's H nu, not V.
Mu.
Okay, I will write it here. H is the Planck's constant. Planck's constant. And this is the nu is it is read as like this nu. So it is the frequency. Nu represents the frequency. So can you first off tell me that your light, sunlight, it is made up of photons, isn't it correct?
Yes, sir.
And these photons, they have energy, and that energy is given by the formula that is h nu. So that's why I can write h nu in presence of sunlight, in place of sunlight. Got it now?
Yes.
Yes, you will note down this, that
Yes,
E is
sir.
here the energy.
Sir,
E
is
is here.
this photolytic reactions used in solar panels?
Yeah, light is made up of photons, and photons have the energy, and that energy is given by this equation, that is E is equal to h nu, and h is the constant, Planck's constant, and nu is the frequency. Nu is known as frequency. Also here you can remember that this silver, it is having the gray color, which we obtain here. So these are the photochemical decomposition reactions, are what we call as photolysis. So have you noted down these reactions?
Yes, sir.
Okay, then we are having the last one in this decomposition reaction, that is known as electrochemical decomposition. Electrochemical decomposition, correct?
Yes. Or
Electrochemical,
electrolytic.
exactly, it is known as or electrolysis. So that means this type of decomposition reaction, it takes place in presence of electricity, right? Electrocurrent.
H2O in presence of electricity.
In presence of electricity. So we have to pass the electricity in order to decompose a particular compound. For example, when we pass electricity through this water, it gets decomposed to hydrogen and oxygen gas, right?
Yes.
So this is also your decomposition reaction, but this will be known as electrolysis or electrochemical decomposition, because we are here decomposing water by passing this electricity or the electric current. So you can balance this like this, twice. Have you got it?
Yes.
Yeah, for example, if you are having the sodium chloride, it is you are in the molten state, you have melted it, and then you are just passing the electricity. So can you tell me what will be the product?
So sodium plus chloride.
Yeah, you will get the sodium metal, that is your sodium solid, and you will get the chlorine gas. Here you will get both the gases. Hydrogen is your gas, oxygen is also your gas. Correct?
So both these combined are just vapors.
Yeah, we are having NaCl in the molten state, molten form. When we just pass the electricity, we get the sodium. It gets actually deposited, this sodium, at cathode. We will define this, what is cathode, what is anode. And this chlorine gas, it gets liberated at anode. So let us see in detail the electrolysis of water. So have you written down this?
So
I will write it here. Electrolysis of water. We have to study it in detail. Electrolysis of water.
Okay, sir. So can you go to the previous slide first?
Yeah, sure.
Sir, is that a bracket 5 near N?
No, it is S. S stands for solid. It is S.
Oh.
S stands for solid and L stands for liquid and G stands for gas.
Okay, sir. Okay,
Got it now?
thank you. Yes, sir. Thank
Yeah, small L in the parenthesis bracket, that stands for liquid if it is written anywhere. Okay, so now I was just saying electrolysis of water. We have to study it in detail, how actually it takes place. So see, first of all, here we are having an electrolytic cell, and that is just like this. We are having a beaker or a container in which we are just having this water. So this is my electrolytic cell in which electrolysis is carried out, right? Inside this electrolytic cell, we are having the two electrodes. One is actually known as anode and another is known as cathode. So have you heard these two names, anode and cathode?
you. Anode is the positive terminal and cathode is the negative.
Okay, I will tell you that this is your one of the electrode known as anode, and then we are just having the another electrode which is known as the cathode. So this is your cathode.
Anode is positive, cathode.
So anode is your which pole? Positive.
Positive.
And cathode is your negative pole, right? Yeah. So now that means this positive anode, it will be connected to the positive terminal of the battery, and then this negative, that is the cathode, it will be connected to the negative terminal of the battery, right? So here it is a battery which
Yes.
is giving the electricity, right?
Yes.
So here you will note down that this is your battery through which we can pass the electricity. And when we pass the electricity, so inside this electrolytic cell, we are having the electrolyte. That electrolyte is actually your water. But can you tell me, is pure water good conductor of electricity or bad? Pure water.
No, sir, it's a bad conductor of electricity. We need to add minerals or salts to make it
Exactly.
conduct.
Exactly. We add some few drops of sulfuric acid. So H2SO4 few drops we are adding here in order to make it good conductor of electricity. Got it?
Yes.
Yes. Now, when you just pass the electricity, what happens? This water, it gets decomposed. It forms H positive ion and it gives you OH negative ion, right? Now, can you tell me where these H positive ions will go and where these OH negative ions will go?
So the positive hydrogen ions, they'll go to the negative terminal, while
Exactly.
the OH minus will go to the positive.
That means this H positive, it will just move towards the cathode, isn't it?
Yes, sir.
Exactly. And then these OH negative ions, they will just migrate, they will move towards this anode, right? Got it?
Sir.
Yeah. So now let's write the reactions, what actually happens at anode and at cathode. So at anode, you will remember that at anode there occurs oxidation, right? We will study
Yes, sir.
this, what is actually oxidation. So we are at anode,
So
ion.
oxidation is addition of oxygen or removal of hydrogen.
Exactly, that is one of the definition, that oxidation is the addition of oxygen or removal of hydrogen. But it has another definition that oxidation means loss of electron. So at anode, we are having OH negative, right?
So,
So it will just lose electrons.
yes,
So
sir.
what it will form? It will just form you the water, and you will also get the oxygen. So you can just balance it by taking it 4 times and twice. And it will just give you the
Sir, so since we have to add a few drops of sulfuric acid,
yeah.
shouldn't we write H2O plus H2SO4 on passing electricity gives hydrogen and oxygen?
Exactly. When you actually pass the electricity, this sulfuric acid, it will also ionize, but we will have, okay, what will be the ions? Ions will be H positive and SO4 divalent negative. These ions. So you have to just do the electrolysis of water. And we are only having the few drops of this sulfuric acid. So H positive ions, they will just move towards the cathode, and OH negative ions, they
Okay.
will move towards the anode, and they will undergo oxidation as compared to SO4 2 negative.
Okay.
Okay, so this is at anode. Now, can you tell me what will happen at cathode?
So at cathode, high reduction, sorry.
Exactly, at cathode reduction will take place. So what is reduction? When oxidation, I
So
told you it is
reduction is
the loss of
addition of
electron.
oxygen or removal of hydrogen.
Reduction is addition of hydrogen or removal of oxygen. Yeah, that is the one of the definition. But another definition is that reduction means gain of electron. So that means this H positive ion, it will just gain electron. So
Or
then
loss
it
of
will,
proton.
yeah, H positive is known as proton. But when we are having these two, so it will become H, and then what actually happens, the H and H, they will combine and they will form H2 gas. So that means at cathode, hydrogen gas gets liberated, correct? And this is very important, and I hope you will note down this, that at anode, oxygen gas gets liberated, and at cathode, hydrogen gas gets liberated. I noted down this.
Yes, sir. Yes, sir.
Okay, I will write it here on the next page. That during electrolysis of water, during electrolysis of water, hydrogen gas gets liberated at, hydrogen gas gets liberated at cathode, and oxygen gas gets liberated at oxygen gas gets liberated at anode. Got it? Have you noted down this?
Yes, sir. Yes,
Exactly.
sir. I'm the only one in class.
And also you will remember another point, that is hydrogen gas, also hydrogen gas liberated
So what is
is double than, yeah, what are you saying?
What is
Liberated means when it gets released.
Oh,
Also, hydrogen gas liberated is double than oxygen gas. Got it?
sure.
Yeah. So that is why when we write the formula of this water, what we write? We write H2O, right?
Yes, sir. Yes,
So
sir.
now have you got this? This is very important. That why is the formula of water? Can you tell me why it is not HO? Why it is not HO2? Why it is not H2O2? Why it is not H2O3?
Oxygen balance is 2.
Exactly, oxygen valency is 2. That is correct. But here experimentally, what we find that hydrogen gas liberated, it is double than the oxygen gas. So that is why we write H2 and O1. Have you got it now?
So there's more hydrogen than oxygen.
Exactly, we write H2. H2 means it is liberated double, and we write O1. That means oxygen is half that as compared to that of hydrogen. Got it now?
Yes, sir. I'm the only one in class. Everyone else left.
What are you saying?
Sir, I'm the only one in class. Everyone else left.
I'm not getting. I'm just saying that in electrolysis of water,
No, sir. I get it. I'm just telling that I'm the only one in class. Everyone else left.
why they have left?
I don't know, sir. Should I call them and ask?
Yeah, sure. You can just call them.
Just
Tell
one
what
second.
is the.
I'll be back. Sir, I called Niti. She said she has a power cut.
Okay, another one.
Sir, rest two are traveling, sir. Sankalp is in Delhi and Tarun is traveling. Nitish has a power cut.
Okay. So why they are traveling this time if they already know that it is the class time?
Sir, no, sir. Sankalp went for a long trip. Sankalp and Tarun both went for a long trip. Looks like they've informed the class, the learning room.
Okay, so shall we continue or shall we stop here then?
Sir, I think class is supposed to end at 6:30.
Okay, no problem. Right, so I hope that you will revise each and everything from this, and let's continue on Thursday, right?
Yes,
Any
sir.
doubt, any question?
No, sir.
Okay. Have a nice day ahead.
Thank you, sir. Bye.
Most welcome. Bye.